This is problem number 7 on the sample test problems for test number 3. In the following graph, the dashed line gives the cost in thousands of dollars of producing an item as a function of the number of items in thousands produced. The solid line represents the revenue in thousands of dollars from selling items as a function of the number of items in thousands sold. So before we get to the questions, let's go ahead and just write some letters here. So the cost apparently is the dashed one, so we'll call that one there C. And then I'll use purple for the other one. It says the solid line is the revenue. So that's R. Okay, part A. What number of items should be produced and sold to maximize profit? Okay, we know that the profit in English is the revenue minus the cost. So we can write that in symbols like that. And we're looking to maximize the profit. That is to say, we want the profit to be as big as possible. Well, looking at the picture, we know that profit is revenue minus cost, so the profit is just the difference between the Y values at any particular point. So for example, if you decided to sell 2,000 units, say you picked that particular X, you could go up here and you'd find one particular revenue, and then up here is the cost. That's the revenue, that's the cost. And the difference between them, that vertical distance, so maybe I'll get rid of some of this stuff. So the vertical distance that I've written up there in red, the length of that vertical line segment, that's your profit. And so you want that to be as big as possible. So it feels like it's even bigger out here than it is right here. But actually it's worse in the beginning because we know that the revenue is supposed to be bigger than the cost. And so actually the vertical line segments here represent a negative profit. These are losses. And if you go out here and draw some vertical lines, those are also losses. So we don't want to be in the red, we want to be in the black. So we want vertical lines in here. Isn't that great how that worked out, the red and the black? So we're looking for basically the longest vertical black line, and you're just going to estimate it. So it feels like, you know, somewhere in there is our guess. So I'll just drop straight down and ballpark it at somewhere around 11,000. Okay, that's not really a calculus thing that we did. So let's do some calculus instead. But thinking of just the vertical distances here, I feel pretty good about an answer somewhere between 10 and 12. So let's see if we can get rid of some of this stuff here and try it the calculus way. Okay, so let's relabel. Blue is cost, purple is revenue. Okay, so the calculus way is to think about derivatives. And so let's pick a particular point. This time I'll pick x equals 6. And I'm going to draw two different points. So let's go to the blue, up to the blue curve, which is the dotted one. So that's the cost when you sell 6,000. And we'll do in purple the revenue at the same 6,000. And what I want to think about is derivative, slope of tangent line. So I'm just going to draw a little tangent line on the blue. So that one's pretty horizontal, still uphill, but fairly horizontal. And the purple one is definitely steeper uphill. And so what's going on here with trying to maximize profit? Well, one thing that we saw in class is that the maximum profit occurs when the marginal revenue is equal to the marginal cost. And marginal is just the economics word for derivative or instantaneous. So at these two tangent lines, at a production of the 6,000 units, the marginal cost is the slope of that line, and the marginal revenue is the slope of that line, and they're not equal in this case. Those two lines are not parallel. So you're looking for two tangent lines which are parallel to each other. And so again, this is just kind of a little game where you just say, okay, they're not parallel there, but if we move a little bit to the right, how about we move over to here? And again, we'll go up to that guy and put a blue dot, and then we'll go up and put a purple dot. And then you draw two more tangent lines. And so the purple one is maybe a little less steep than the first purple one. And then the blue one is maybe a tiny bit steeper than it was before. And if you keep plodding along, just keep chugging to the right, eventually you'll find a place where those tangent lines are parallel. And wherever that happens, that's where the profit is maximized. So, so let's just go ahead and see if we can eyeball where the best one is. Feels like, okay, I guess I'm cheating because I already guessed my answer was 11,000 before, but if we pick 11,000, and then we'll put the purple dot straight up here on the revenue, so 11,000, purple dot is up there. And then the blue dot on the cost is down here. And if no one's looking again, I'll highlight that the vertical distance is the profit, and that's the biggest vertical line out of all these different profits, and these are losses out here. So get rid of all that. And then just draw two little tangent lines. And if we have found the maximum profit point, then there's something very special that should be true about these two tangent lines. So there's my first tangent line, and then my second tangent line. And in theory, if we found the maximum profit point, as you might have guessed, those two tangent lines are supposed to be parallel. So we'll just write a little bit down here. We've explained a lot of stuff, but we'll write a little bit. We want two parallel tangent lines. It looks like that happens at about 11,000 units. Part B, estimate the marginal revenue at the point you indicated in A and explain its meaning. Okay, marginal revenue, so we're looking for the purple one up there, and we know that the marginal revenue is the slope of the tangent line. So let's just see if we can't estimate the slope of that purple line. One thing I'd caution you to do, we want to find the slope of this line. Do not pick points that are real close to that point and try to estimate the slope, because there's a lot of room for error when you pick points so close to each other. So for me, I like to draw my tangent line really far in both directions and pick points that are far away from each other. So just eyeballing your tangent line, not necessarily mine, see if you can find 2 points that are nice, that are on the grid and also on the tangent line. So for example, for me, I'm looking at the point 415. I'm going to put a dot on that in 1 second, but at 4,15, looks like that purple line goes pretty close to that point. And then as we run to the right, are there any other nice points that we can find? I actually don't see another one that's as nice as that first one. I'm going to go out to 16. And if I go out to 16, it looks like it's not too far from being, I'll just call it this number up here. Actually, we'll go to the lower one. I'll call it this one right here. And that looks like it's at about 26. It's maybe a little bigger than that, but that's okay. So we'll say this one is at 1626. And this one over here is at 415. And I want the slope, so we just do a slope calculation. No more calculus in this problem. So the marginal, what are we doing in this one? This is the revenue. So the marginal revenue is equal to the slope of that particular purple tangent line. And then we'll just do our change in y over change in x. 26 minus 15 over 16 minus 4. So that's 11 over 4. And if we want a decimal, that's 3.75. Okay, pause the video because I knew 3.75 was not a number that I remembered from looking at the answers before I did this video. And it's because I don't know how to subtract 16 and 4. Should be 12. So I got 11 over 12, which is just a little bit under 1. So we can type that in if we want a decimal. It's okay to leave it as the fraction. And so we'll quit out of here and type in 11/12. And so we get about 0.92, 0.916. Say 0.917. And I actually kind of like that the answer I got here is not really all that close to the answer that's in the answer key. In the answer key, I think it says 0.67, and 0.9 is fully 50% more than that. But that's okay. It's just a ballpark question. You're trying to estimate the slope of the line, and if I did this problem again and just started from scratch, I'd probably get a different number than either of the two that we've just mentioned. So that's okay. There's a wide range of acceptable answers here. Let's go ahead and explain the meaning for this one. So this 0.917, if we get the units, I think that will help. So the units upstairs, 26 and 15, I think the units upstairs were dollars, weren't they? That was the revenue we get for producing the different amount of goods. So the units upstairs is dollars, and the units downstairs is number of items. So I guess what this means is that if you sell 11,000 items, then the revenue is changing at about $0.917 per item. So you can say it just like that. You could also say that the revenue for selling, maybe the revenue from selling, one more item, the 11,000 first item, is roughly 92 cents, $0.917. Let's see, estimate the marginal costs at that same point. Okay, what you could do is maybe extend that blue tangent line on the cost function both directions, find a couple of points that appear to be close to being on the grid, do another slope calculation. But if you're on the ball, you recognize you don't have to do any of that. The whole point is that at the max profit point, the marginal revenue is equal to the marginal cost. Those were parallel tangent lines. So our answer to this one is that the marginal cost is equal to the same 0.917 we got before, dollars per item. And so what's going on? All right, if you sell the 11,000 first item, you're going to get about 92 cents in revenue. But this latest answer tells us that we're also going to lose about 92 cents because that's what it costs us to produce and sell that item. So how much profit do you gain from selling that 11,000 first item? The answer is none. You don't get any. Let's see how that looks when we write it up here. We know that the marginal profit is just the derivative of the profit. So I'm going to take this equation and I'm going to take a derivative of everybody. P prime equals R prime minus C prime. Said another way, marginal profit is equal to marginal revenue minus marginal cost. And if you happen to be at a place where the marginal revenue equals the marginal cost, that's where we were from parts B and C, then the marginal profit is 0. Does it make sense? Absolutely. You are gaining no profit by selling that 11,000 first item. Revenue is 92 cents, but the costs are also 92 cents. So the marginal profit, the change in profit for selling that 11,000 first item is 0. E, for what number of items produced and sold would profits be 0? Okay, I think this question is a lot easier than the ones we've just finished. So if we want the profits to be 0, that means we need the revenue and the cost to be equal to each other. So can you look up at this picture and find any places where the revenue and the costs are equal? And the answer is, yeah, there's a couple of points actually. So one of them right here. So let's call that about 3.75 maybe, or maybe it's 3.5, I guess. So at 3.5, the two curves hit each other, and then way out here, so maybe that's about 17.5. The two curves hit each other. Again, it's not perfect, so there's a range of acceptable answers. So for what number of items produced, I guess I'll say at 3,500 and 17,500 items, revenue and costs were equal. So the total profit at either of those quantities is 0. About where are the marginal profits the greatest? Explain. Okay, this is kind of tough. I think it's difficult to visually see the marginal profit from the picture that we're looking at up here. The reason it's difficult is that we don't have the profit curve given to us. It's just not in this picture. If the profit function were drawn, then the marginal profit would just be slopes of tangent lines. And those are it's easy to maybe estimate where the steepest tangent line occurs. But here, I think what we're going to do is just kind of ballpark, start looking at a few of these tangent lines and see if we can make them change as fast as possible at the same moment. At least the difference between them hopefully is as big as possible. So if, for example, you were to start here at x equals 0, so we'll draw the cost tangent line in blue, and we'll draw that's not very good. So the cost tangent line in blue, and then in purple we'll draw the revenue tangent line. And so if you find the difference between those slopes, then you're finding the marginal profit. Say it again, difference between those slopes is the marginal profit. Why is that true? It's true because of what we wrote right here. Marginal profit is the difference between the marginal revenue and the marginal cost. So I want the difference to be as big as possible. So okay, I don't feel like doing a lot of slope calculations, but there's a difference between those slopes, that's fine. And then if we move over to the right, maybe let's look at that red point. Maybe the slope for that one is that, and then the purple one is actually pretty steep at this spot. And so you can subtract the slopes at that point. Actually seems like the two slope calculations at those 2 points are not very different. That is to say, the difference in the slopes of these two is maybe not so far from the difference between the slopes of those two. Again, it's just visual stuff. But I definitely know that as we approach the point here in black, as we approach that point in black, we get to these tangent lines that are here, and those tangent lines have the same slope. And we don't want that at all. We want the slopes to be very different from each other. So maybe the answer is someplace way out there to the left. I think in the answer key it says it's pretty close to the point of intersection. You might also take a look as we go here to the right. I'll go ahead and put the red dot at this one. You don't have to pick the point of intersection. Technically, we should be looking at every point. But maybe the tangent line here is some little bit downhill, not very steep. And the tangent line here is uphill, kind of steep. And again, thinking about difference between those slopes, I don't know. It's not easy to answer this question. So I just looked up the answer in the answer key. It says the answer is at about 3,000, so somewhere not too far from this point that we were looking at before. If you gave me 2,000, that's okay. If you give me 10,000, that's not okay, because at 10,000, the tangent lines are nearly parallel. So I guess all I want to say about this one is that we want, what do we want? We want to be pretty far from that place where things are parallel. So get far away from that place where the profit was maximized. And then one other thing before we move on from this question and do the very last one is that I guess I was a little bit careless when I said that, you know, we can compare maybe these 2 points, and we could also compare these 2 points. But actually, for one of those sets, the marginal profit is positive, and for the other one, it's negative. And if we want the marginal profit to be the greatest it can be, we're looking for positive things over negative things. So I guess what we're saying is, it's circled in purple there, marginal profit is marginal revenue minus marginal cost. If I want marginal profit to be big, I suppose I'm saying the marginal revenue has to be bigger than the marginal cost. So we want places where the revenue tangent lines are steeper than the cost ones. So the revenue tangent lines to be steeper, I think that means we're towards the left-hand part of this picture. So don't pick that point out there to the right. So I'll put the answer that's in the answer key. Again, I don't know. Just pick something way to the left on this picture and I'll give you credit for it. And then finally, G, what theorem guarantees the existence of a value A between 0 and 10 such that C prime of A is equal to the average rate of change between x equals 0 and x equals 10. All right, I'm hoping that there is some theorem that just pops in your mind looking at all the information here. There's a C prime, that's the slope of a tangent line, compared to the average rate of change, that's the slope of a secant line. The theorem that relates those two things is called the mean value theorem. And so we're going to try to estimate the value where the tangent slope on the cost. So let's see if we can start translating. This is the tangent line of the cost function. It's supposed to be same slope as the secant line of the cost function between 0 and 10. So average rate of change tells you secant line. So x equals 0, x equals 10, focusing only on the cost curve up here. So the cost one is the one with all the blue on it. So I don't want to put any more blue. I'll use green. We're looking for 0 and 10 on the blue curve. So 10 is here. 0 is here. We want the tangent, sorry, the secant line that connects those two things. And then I want to try to find some place between 0 and 10. So it's going to be somewhere in here. I'll stop before we get there, where the tangent line for the cost function is parallel. Okay, so all we're looking for is a place on the dotted curve where the tangent line is parallel to that green line that we've drawn. And so I don't know, maybe someplace around here. There's a lot of stuff happening in there, so now it's hard to see. But we're just looking for something which is roughly parallel to the tangent line. And so bring this guy straight down and get some number, something around 3, 3.5. Again, there's a wide range of acceptable answers. Anything nearby 3 is good enough. So we'll just say roughly A equals 3, or 3,000 units in this case.